Okay, so for part C, it asks us to derive an expression for t. So we're going to start with our expression that we found earlier right here. Fg minus t is equal to ma. So we're just going to go straight to that. We'll put mg minus t is equal to ma. We will just add the t and subtract the ma, leaving us with mg minus ma is equal to t. So it asks us to find the t in the terms of m, g, and a. So technically you could leave it at this, but we're going to simplify this a little bit further. We're just going to take m out, make g minus a, set that equal to t, and that is our answer. So that is part C. Now move on to part D. So for part D, it asks us if increasing the mass of big M will have an effect on the acceleration and the tension. So the answer to that is yes. So we already found that A is equal to mg over m plus big M. So due to this, we know that if big M is increased, that therefore A must decrease, meaning they have an inverse effect on each other. And we also have already solved for t, as we know that t is equal to mg minus a. And since we know that when big M goes up, that a goes down, and since a here is being a subtracting vector, that means the smaller that a is, the bigger t will be. So since we know that a is decreasing, we know t will be increasing. Okay, that is part D. Next is part E. So part E asks us to derive an expression for acceleration in this new system that also includes friction. So where to first start is Fg minus t is equal to ma, just like before. But now when we solve for t, the net force on block big M or block S is equal to big MA is now two forces, so it will be T minus F of K is equal to big MA. And we know that F of K is just the F of G or mg times mu K. So we have T minus mg mu K is equal to MA. And we could just add mg uk onto the other side, giving us t is equal to ma plus mg uk. So we can now plug that into our formula before, giving us mg minus ma plus mg uk is equal to ma. Then what we want to do is add this onto the other side to isolate for A. So we'll get mg is equal to ma plus big Ma plus big mg mu k. So from here, we can just take the A out of this, meaning that we have mg is equal to a m plus m plus mg uk. So we'll just subtract this onto the other side and divide by m plus m, giving us mg minus mg mu k over m plus m is equal to A. So that is our expression for part E. Next, part F asks us to derive an expression for tension. So for that, we'll just start with what we had before. So we have mg minus T is equal to ma. We can flip this around by adding T and subtracting ma to give us T is equal to mg minus ma. So once we're here, all we're gonna do is plug in what we got over here for our A. So we will get T is equal to mg minus m times mg minus big MG mu k over small m plus big M. And so that is our function for T. Right there. Our next question is part G, and asks if with friction present, if the tension in the string between the blocks will increase, decrease, or remain unchanged. So the answer for that is T is equal to big MA plus FK. And because of this, we know that if FK goes up, that our T would also go up. Next is part I, or part H. And H asks us to draw and label a free body diagram showing all the forces acting on each block at the points at which the forces act. But now we have an additional mass. So for block S, there is a force of block little m acting on block S. There is a tensional force which is pulling the block. There is again an FG and an FN which cancel out with each other, and there is an FK which is present. So that's all the forces for block S. So next is block little m, and this one also has a force of Fn and a force of Fg, which are equal to each other. And then there is a force of block S pushing on block little m that is pulling it, and there is a force of friction. We can call this FKM because this is the FK specifically for block little m. Lastly, there's block H, and we know that there's still just a tensional force pulling up on this block, now greater than before, and there is an FG which is pulling it down, and the rest of the system as well. Now for part I, it asks to calculate the acceleration of the system. So first step here, step sigma F equal to MA, this is being MH, and we will take FG minus T is equal to MHA. And then we just need to solve for t over here. So we will be using sigma f is equal to we'll call this mxa. This is the total masses on the x plane sitting on the table. So we will show that T is the force pulling the two blocks to the right. We do minus Fk is equal to M plus big M A. So T minus M plus M G mu K is equal to M plus M A, and we just have to add this to the other side, giving us T is equal to M plus M A plus M G mu K. So this question gives us numbers, or values, so we can plug in the numbers now. So big M is equal to 2 kilograms, small m is equal to 3, and mu K is equal to 0.18. So we'll find the tension here. So this is equal to 2 plus 3A plus 2 plus 3, 9.8. 0.18. So here, this is all equal to 5A plus 4.057. So now we can go back to our function before. Fg is just equal to mg minus 5A plus 4.057 is equal to ma. So we can now plug in our numbers once again. So we know the mass is 3, gravity is 9.8. Gravity in this is going to be considered to be positive because it is taking us in the positive direction, as we're taking the direction that the masses are going as the positive direction. So now we are subtracting by 5A plus 4.057, and we'll set that equal to 3A, as that mass is equal to 3. We can then move these to the other side, so we have 29.4 is equal to 3A plus 5A plus 4.057. We can add these two and subtract 4.057, leaving us with 25.34 is equal to 8A. Divide by 8, divide by 8. We get 3.167 meters per second squared is equal to A. So that will be our A for this system. Now moving on to part J. We just set T, as we found before, T is equal to M plus M A plus M G mu K. And then once again we just plug in all the numbers like before. So we had already found that it is equal to 5A plus 4.057.